Hello, welcome to a new video. In this video we are going to see a problem that can be solved using quadratic reciprocity law. Find whether the problem is that you need to find whether 219 is quadratic residue or quadratic non-residue mode 383. The number is 383. Given number is. So you can answer this question very effectively if you know the value, the Legendre symbol value 219 for 383. 219 bar 383. If this value equal to plus 1, then the answer is positive. That means the number is 219 is quadratic residue mode 383, and if on the other hand, if it is minus 1, then the answer is that 219 is a quadratic non-residue mode 383. But for that, one point should be verified, and that whether 383 is a prime number. So if 383 is a prime number, then you can proceed using this. Okay, but we know that 219 is not a prime number. 219 equal to 3 into 73. But further is 73. What about the number 73? You can see here that 73. Yeah. Okay, 73 is also yeah, it's a prime number. Yeah, since 73 is a prime number, then we can you cannot further you cannot divide it into factors. So 219 is equal to 3 into 73 is the prime factorization. Therefore you can write that 219 bar 383 is equal to 3 into 73 bar 383 using the completely multiplicative property of Legendre symbol. You get that 3 bar 383 into 73 bar 383. But you need to find the these two values separately. 3 bar 383, you need to find 3 bar 383. Since 3 and 383 are prime numbers, okay, we can apply the quadratic reciprocity law. You can apply that quadratic reciprocity law states that P bar Q in the Q bar P, where P and Q are two prime numbers, then the answer equal to minus 1 raised to P minus 1 by 2 into Q minus 1 by 2. Here P equal to 3 and Q equal to 383. We can take that, and therefore it becomes, thereby expression now becomes 3 bar 383 into 383 bar 3 is equal to minus 1 to the power of 3 minus 1 by 2 into 383 minus 1 by 2 equals minus 1. Therefore okay, we also know that we also know that P bar Q equal to 1 by P bar Q. P bar Q equal to 1 by P bar Q, and therefore okay, we have established that that result already, and therefore 3 bar 383 is equal to 1 by, using that 3 bar 383 equal to 1 divided by 3 bar we get here that 3 bar 383 using in the previous step we get the 383 bar 3 bar 383 into 383 bar 3 equal to minus 1, and therefore using this step here you get that 3 bar 383 equal to 1 divided minus 1 divided by 383 bar 3 minus 1 by 383 bar 3, but this is in the denominator, and but 1 by 383 1 divided by 383 bar 3 is equal to equal to 383, equal to 383. 1 divided by 383 bar 3 equal to 383 bar 3. So you can write the answer equal to minus 1 into 383 bar 3. But you can but we need to find the value 383 bar 3 using the periodicity of the Legendre symbol. Since we can write that okay, 383 bar 3 is equal to, okay, since we can write 383 bar 3 is equal to 383 plus 3k bar 3. So where k is equal to minus 10, see, minus 100. Okay, and this is this way you can here we are applying the periodicity actually. Since we when we add 3 times of some number k, suppose we add 3 times some integer k to the number 383, then we get that we are that way we are reducing the value to a lower number. The Legendre symbol value is now reducing, is step by step reduced to a lower number. So that is 383 bar 3. Here you can see 383 bar 3. When we take k is equal to minus 100, then we get that 383 bar 3 is equal to 383 minus 300 bar 3 equal to 83 bar 3. So suppose we take on the other hand, if we take k is equal to minus 127, see, you can write that 383 bar 3 is equal to 383 minus 3 into 127 bar 3 equal to 2 bar 3. Therefore so in short you can see that 383 is congruent to 2 mod 3. 383 is congruent to 2 mod 3. So for that this calculation is done. Therefore you get that 383 bar 3 is equal to 2 bar 3. But 2 bar 3 using that theorem 9.5, I think, using theorem 9.5 or some theorem in the some important theorem in chapter 5, you can write that 2 bar p equal to minus 1 raised to 2 bar p equal to minus 1 raised to p square minus 1 divided by 8. Yeah, when but that value equal to minus 1 if p is congruent to 3, if p is congruent to 3 mod 8, and equal to plus 1 if p is congruent to 1 mod 8, and therefore you get that 2 bar 3 is equal to minus 1. After verifying this after verifying that this is the case that p is congruent to 3 mod 8, okay, then you get that answer 383 bar 3 is equal to minus 1. Since this is that case, this is the case in the current situation, we have p is congruent to 3 mod 8, and therefore we obtain that 383 equal to 383 bar 3 equal to minus 1. That value can be then substituted there. Again we can apply the similar procedure can be applied to obtain 73 bar 383. Both are odd primes, so we apply the quadratic reciprocity law, then and we get that 73 bar 383 into 383 bar 73 equal to minus 1 to the power of 73 minus 1 by 8 into 383 minus 1 by 2 73 minus 1 by 2 into 383 minus 1 by 2 equal to 1. Hence 383 bar 73 equal to 1 divided by 383 bar 73. Okay, but you need to find 383 bar 73, but that equal to 18 bar 73, and directly you can find the value. Okay, 383 bar 73 equal to 18 bar 73. Why? Because Okay, because of this is obtained because of the periodicity, applying the periodicity property of a Legendre symbol. Then you can find you can find 18 bar 73 that equal to 2 into 9, because it's a number, a composite number, so 2 into 9 bar 73 equal to 2 bar 73 into the Legendre symbol 2 bar 73 into 9 bar 73, but 9 bar 73 equal to 3 bar 73 into 3 bar 73. There we get a positive 1 plus 1, so it reduces to 2 bar 73. Hence 18 bar 73 reduces to the number 2 bar 73 into 1. The 2 bar 73 can be calculated, can be determined using the relevant part of that theorem, 9.5. Okay, we can obtain 2 bar since 2 bar p equal to 1 if p is congruent to 1. 2 bar p equal to plus 1 if p is congruent to 1 mod 8. In this case, you can verify that the number p in this case equal to 73. 73 plus 1, 73 plus 1 equal to 7. Oh, sorry. 73 minus 1 equal to 72. 72 and 9 into 8. Yeah, that can be 72 can be divided by 8. Okay, and therefore that means p is congruent to plus 1 mod 8. The situation, correct situation is that p is congruent to plus 1 mod 8, and therefore you can apply the first part of that result and write that 2 bar p equal to plus 1. So 2 bar p, in this case p 2 bar 73, 2 bar 73 equal to plus 1. Okay, thus we have got the answer here. This is here we get 1 into 1 and that equal to 1, that is 18 bar 73. Therefore 18 bar 73 equal to 1. Okay, and then using these quantities there in the previous steps, we get that the final answer for 219 bar 383 equal to plus 1. 219, since 219 bar 383, if it is plus 1, then we can conclude that the given number 219 is quadratic residue mod 383. So see another question. Another question we have. Determine, the question reads as determine determine those odd primes p for which 3 is quadratic residue and those with which it is non-residue. Find those odd prime numbers for which 3 is quadratic residue and find those with which it is non-residue, quadratic non-residue. Here the solution can be to obtain the solution. Let's write 3 bar p. Yeah, we consider 3 bar p, and we want to find 3 bar p 3 bar p to get the answer. We want to know the answer, the value of we want to know the value of p. Actually we want to find the value of p for which 3 bar p equal to plus 1. For those values of p, 3 is a quadratic residue, and for those values of p for which 3 bar p equal to minus 1, 3 is quadratic non-residue. So 3 bar p equal to, but by applying the quadratic reciprocity law, you can write that. Yeah, first applying the quadratic reciprocity law, this is the step. 3 bar p into p bar 3. 3 bar p into p bar 3 equal to minus 1 raised to p minus 1 by 2 into 3 minus 1 by 2. P minus 1 by 2 into 3 minus 1 by 2. Multiplying both sides by p by 3. But this can be simplified by multiplying both sides by p bar 3. We get that p bar 3 into 3 bar p into p bar 3, p bar 3 into p bar 3. Okay, we get that here, but p bar right side becomes p bar 3 into minus 1 raised to p minus 1 by 2 into 3 minus 1 by 2. After simplification, we have here p bar 3 the whole square, so that equal to plus 1. Therefore p bar 3 3 bar p into plus 1, 3 bar p into plus 1 equal to p bar 3 into minus 1 to the power of this. Here we have 2 by 2 equal to 1. Okay, p minus 1 by 2, it reduces to p minus 1 by 2. Therefore 3 bar p equal to p bar 3 into minus 1 to the power of p minus 1 by 2. So the value of 3 bar p depends on, thus we can say that the value of 3 bar p depends on the value of p bar 3, and the value of minus 1 to the power of p minus 1 by 2 into 3 minus 1 by 2. To obtain the value of 3 bar p, we must consider the periodicity of the value of p depending upon the value of p. We must consider the periodicity and the value of p depending upon, we must consider the periodicity of which quantity? Periodicity of the Legendre symbol. We must consider the periodicity of the Legendre symbol, and also depending upon the value of p, it must be depending upon the value of p. We have two possibilities now. In this considering this, we have to discuss two possibilities. P bar 3 p is congruent to 1 mod 3. First situation is p is congruent to 1 mod 3, and the second situation is p is congruent to 2 mod 3. P is congruent to 1 mod 3 and p is congruent to 2 mod 3. In the first case, when p is congruent to 3 when p is congruent to 1 mod 3, we have that p bar 3 equal to 1 bar 3. Okay, if p is congruent to 1 using periodicity of Legendre symbol, when p is congruent to 1 mod 3, we can write that p bar 3 is equal to 1 bar 3 because there the remainder is equal to 1 when we divide p by 3. But in the second situation, when p is congruent to mod 3, we have to write p bar 3 equal to 2 bar 3. P bar 3 equal to 2 bar 3. But let's complete the first case, the discussion on the first case. Replacing we get that when p equal to, so when we consider, you can refer the page number 179, table on the page number 179. So it is it is given that if p equal to 3, then 1 is quadratic residue mod 3. When p equal to 3, then 1 is quadratic residue mod 3, and also but 2 is quadratic non-residue mod 3. Therefore 1 bar 3 equal to 1 bar 3, but anyway you can some other way also you can write that. You can write the Legendre symbol value 1 bar 3 equal to plus 1 without referring the any table. You know that 1 bar 3 equal to plus 1, and 2 bar 3 you can use that theorem 9.5. Using theorem 9.5 you can write 2 bar 3 equal to 2 bar 3, the value of 2 bar 3 can be written, then 2 bar 3 equal to minus 1. See, this is the step for that. You can verify whether p is going to plus or minus 1 mod 8 or p is going to plus or minus 3 mod 8. After this verification you can write that you can see that 2 bar 3 equal to minus 1. So to find the value, thus we have two values for the quantity 2 bar 3 in this expression. P bar 3 can be now is reduced to, we have reduced p bar 3 to p bar 3 is reduced to which quantity, since p is congruent to, p bar 3 can be reduced to two cases, and then in the first case we have p bar 3 is equal to, p bar 3 is equal to 1 bar 3, and in the second case we get p bar 3 is equal to 2 bar 3, and in both cases we have the values. First case here we have plus 1, and in the second case we have minus 1. But to obtain the value of the second value, minus 1 raised to p minus 1 divided by 2, we can find that value. We know that minus 1 raised to p minus 1 by 2, that also can be determined using the nature of the number p, the prime number p. We want to obtain the value of this quantity. So when p minus 1 by 2 mod 2, that is if it's an even number, if p minus 1 by 2 is an even number, and then you can write the case 1, p minus 1 by 2 is an even number, that is equal to 2k, and therefore p minus 1 equal to 4k, and that's p is equal to 4k plus 1. In that situation we can write, we can say that p is congruent to 1 mod 4. So if p is congruent to 1 mod 4, and then we get plus 1 here. If p is congruent to 1 mod 4, then plus 1 is the resulting value from the for this or the value of this quantity. And the second situation, we have odd number. P minus 1 by 2 is an odd number, and that is 2k plus 1, and that is p minus 1 equal to 4k plus 2. Therefore p is equal to 4k plus 3. This p is equal to 4k plus 3, that is p is congruent to, so p is congruent to 3 mod 4. So the situation is p is congruent to 3 mod 4. Hence since p is congruent to 3 mod 4, we have that in the second case, in that case what happens to this quantity? It is minus 1. We get minus 1. So whenever p is congruent to 3 mod 4, we can conclude the two situations in this way, and that if p is congruent to 3 mod 4, then we have minus 1, we obtain minus 1 from this quantity, and if p is congruent to 1 mod 4, we get plus 1 from this quantity. And thus we have completely considered all the we have analyzed the situation or the 4 possible cases, but you have to in the first case we have 2 sub cases, and in the second situation we have 2 sub cases, but you have to properly combine these situations, and then how many cases will be there? Cases we are going to get 4 different cases for 1.1, and then and case 1.2, and case 2.1, and case 2.2. So these are the 4 cases corresponding to the 2 into 2 situations, 2 into 2 different situations that we have different values. In the first for the quantity p bar 3, since we have for p bar 3 we have 2 different values, and for minus 1 raised to p minus 1 by 2 we have 2 values, plus 1 and minus 1. So considering these 2 numbers in the product, since we make the product considering the since we want to obtain the value of the product considering the values of 2 values of p bar 3 and 2 values of minus 1 raised to p minus 1 by 2, we get 4 situations. And the case that situations are written here as represented here as 1.1, 1.2, and 2.1 and 2.2. So case 1.1, we assume that p bar 3, we take p bar 3 equal to plus 1 and minus 1 raised to p minus 1 by 2 equal to plus 1, and then the product equal to plus 1, and so in that situation 3 bar p equal to, then 3 bar p equal to plus 1. So this is in this case, we can say that 3 is quadratic residue mod p. So in this case 3 we get 3 quadratic residue mod p. So this is the value. This value is so this is this value is this value is obtained with respect to the condition, using the condition that when the condition is satisfied, p is congruent to 1 mod. Okay, let's go back to the into the discussion. Okay, when we get 3 bar p equal to, sorry, p bar 3 equal to plus 1, let's consider that case. P bar 3 equal to P bar 3 equal to plus 1 when it is 1 P bar 3 equal to 1 bar 3. When P bar 3 equal to 1 bar 3, we get plus 1. And in that situation, what is the condition? Okay, in that situation, we have that that in that situation we have P is congruent to 1 mod 3. So if P is congruent to 1 mod 3, then we have plus 1. For obtaining 1 bar 3 equal to plus 1, but 1 bar 3 will be finally equal to P bar 3 equal to 1 bar 3, but 1 bar 3 equal to plus 1 only when this number P is congruent to 1 mod 3. And the other case is when in the second situation we get minus 1 if P is congruent to 2 mod 3. So this is the case you have to consider. You have to write as the condition. You have to accept as the condition. This is the condition that gives us P the condition is P is congruent to 1 mod 3, and that can give us 1 bar 3 equal to plus 1 or P bar 3 equal to plus 1. So you have to write that condition there in this case, since P bar 3 equal to plus 1, so corresponding to that P is congruent to 1 mod 3. Here we have that condition, but minus 1 to the power of P minus 1 by 2 is plus 1. For that the condition is that P is congruent to 1. This is that situation. Yeah, this is that situation. You get to plus 1. That for that P is congruent to 1 mod 4. P is congruent to 1 mod 4. So these are the two situations, that give that should occur together. These conditions must occur together. So you have to combine the two congruences. That means first congruence is P is congruent to 1 mod 3, and the second congruence is P is congruent to 1 mod 4. Therefore, combining the two, since the occurrence of the two conditions together is essential for obtaining the product 1 into 1. So that is the condition for the first case. The next case is 2.2. Case 2.2. In the case 1.2. In case 1.2, we take P bar 3 equal to minus 1. P bar 3 equal to minus 1, and that happens. P bar 3 equal to minus 1 can happen only if P is congruent to minus 1 mod 3. So that is the we choose that condition. And see, you can see that P is congruent to minus 1 mod 3 can happen only when the numbers are the possible values of P are then 2, 5, 8, 11, etc. These are the values. So in that way, in a similar way, you can write the numbers here also. So condition in the case 1.1. In case 1.1, you can write the values of P that satisfies the first condition. P is congruent to 1 mod 3, and that values are 1, 5. If P is congruent to 1 mod 3, right? Okay, and those values are P is congruent to 1 mod 3. Here this is the condition, first condition. P is congruent to 1 mod 3, and P is congruent to 1, and those values are 1, 7, the values are then 1, 7, 13, etc. Okay, together with when we combine the conditions, and P is congruent to 1 mod 4, we have that we have the values for P. Okay, prime numbers also we need to choose. Okay, those prime numbers which satisfies the condition P is congruent to 1. The first condition is P is congruent to mod 3, and those values are therefore those prime numbers which satisfy that condition is, first condition is 1, 7, 13, etc. and the prime numbers which satisfy the condition P is the second condition P is congruent to 1 mod 4 are 1, 5, 3, 13, etc. And you can list these numbers, and after listing these numbers, for the first condition, these are the prime numbers which satisfy the first condition. And the second condition is satisfied by the prime numbers 1, 5, 13, etc. Then you can compare these two lists. We have two lists of prime numbers, and those numbers which occur together in these lists can be selected. Therefore, first number can be selected as the answer for P, and the second number that comes in this list is 13. Okay, 1, 13, and etc. You cannot exactly, you cannot list out the all the numbers, because there may be infinitely many such numbers, but you can combine, you can write together the conditions. Those prime numbers which satisfy the condition P is congruent to 1 mod 3 and P is congruent to 1 mod 4 together, those prime numbers can be given, can be selected as the values of the the suitable value for P. Such prime numbers can be selected as suitable values for P. Now, in a similar way, we can consider here the case 1.2. Here we have the first situation, P bar 3 equal to minus 1 only if P is congruent to minus 1 mod 3, and the second situation is minus 1 raised to P minus 1 by 2. Minus 1 raised to P minus 1 by 2, that must be which value to get minus 1. See, we get minus 1 from minus 1 raised to P minus 1 by 2 when P is congruent to 3 mod 4. So combining, these are the two conditions that you have to combine. Those prime numbers which satisfy together the condition P is congruent to minus 1 mod 3 and P is congruent to 3 mod 4 can be selected as the number satisfying this this case, satisfying the case 1.2. Okay, then list out, you can list out the prime numbers in the first group, 1, 5, 8, 11, etc. And you can list the other numbers also, other prime numbers also. Then you can select those numbers satisfying this condition. Combining these two conditions, we get that okay, you can combine these two conditions. You have two conditions, you can combine the two conditions and get that P is congruent to okay, since these are minus 1 minus 1, if P is congruent to minus 1 mod 12, those prime numbers which satisfy the condition P is congruent to minus 1 mod 12 can be selected as the answer to this case 1.2. Next case 2.1. Case 2.1, here we consider 3 bar P equal to but for 3 bar P equal to P bar 3 into minus 1 raised to P minus 1 by 2. This is the base equation, and we select plus 1 for this number and minus 1 for this number. Case 2.1, okay, that P bar 3, we select P bar 3 equal to plus 1, and that can happen if P is congruent to 1 mod 3, and this quantity, the second quantity, is minus 1, and that can happen if P is congruent to 3 mod. First case it is P is congruent to 1 mod 3, and the second case P is congruent to 3 mod 4. Okay, and therefore but first condition can be rewritten as P is congruent to here the condition P is congruent to 1 mod 3 can be written, can be modified to get the second quantity, second number same. Then we get that P is, we can see that that's equal to P is congruent to minus 5 mod 3. Since P is congruent to 1 mod 3 is same as P is congruent to minus 5 mod 3, and the second one condition can also be modified to get P is congruent to minus 5 mod 4, and so combining that we can write P is congruent to minus 5 mod 15 is the condition, is the combined condition for that case. Next, last case is next we have to discuss last case, that is 3 bar P equal to P bar 3 into minus 1 to the power of P minus 1 by 2. Here we have to select minus 1 for this, and for this number, and plus 1. We assume that this is minus 1 and this quantity is plus 1, and for based on our assumption, the condition is satisfying, the condition satisfying this assumption is or giving us the value minus 1 for p bar 3 is 2 is congruent to p is congruent to mod 3, and the second number plus 1, we get plus 1 here if p is congruent to 1 mod 4. But that can be written as p is congruent to 5 mod 4, p is congruent to 5 mod 4, and again p is congruent to p is congruent to mod 3 can be written, p is congruent to 5 p is congruent to mod 3 can be written, it's equivalent to p is congruent to 5 mod 3, p is congruent to 5 mod 3. So combining these two conditions, we get that p is congruent to 5 mod 12. So that is the condition. P is congruent to 5 mod 12 is the condition that must be verified to get the value of p. Okay. And therefore, and thus we have discussed all the cases, all the 4 cases, and these are and we have obtained the conditions, corresponding conditions, that can give us the value of p, which satisfy the, or which generate the situation that 3 is quadratic residue or 3 is quadratic non-residue mod p. Okay, thank you.